Good morning to all. In this session, we are going to discuss Fourier integral and its subintegrals, that is Fourier sine integral, Fourier cosine integral. Okay, let us start. Now just look at. Now just we are going to discuss Fourier integral. From this, we are going to discuss Fourier sine integral. After that, Fourier cosine integral. Now we have to discuss this in this session. Now, Fourier integral of any signal or function f of t, that is equal to 1 by 2 pi integral minus infinity to infinity and minus infinity to infinity the function f of t into cos u of t minus x, look at t minus x dt du. Understanding? dt du. So this is the Fourier integral format. Or generally, what we write is, no need to write t always. You can make it x also, is a function. Both are same. F of x is equal to, in this case you can write f of x also, cos u of t minus x dt du. Both are same, mathematical or function or signal. Now just look at how many variables are here. U, t, x, 3 variables are here. 3 variables. How many integrals are here? 2 integrals are here. This one is t, another is u. Out of u, t, x, one integral for u, another integral for t, the output is x. Left hand f of x, that is equal to f of x. Understanding? Now this is the Fourier integral format. The same format, Fourier integral of the same format, they can be written as 1 by 2 pi of minus infinity to infinity minus infinity to infinity f of x into cos a minus b formula. This is of the form cos a minus b. So it can be written as cos ut minus ux. This is of the form cos a minus b. That means cos a cos b plus sin a sin b. That is sin ut into sin ux of dt du. Now just look at, it is split into 2 terms. So this is equal to 1 by 2 pi integral minus infinity to infinity integral minus infinity to infinity f of x into cos ut into cos ux dt du plus same thing 1 by 2 pi minus infinity to infinity, again minus infinity to infinity. This is f of x into sin ut into sin ux, that is dt du. Now, since the internal part cos is even, product of 2 events is even, sin is odd, product of 2 sines is equal to odd. Therefore, here 2, 4 will come out. That will become pi by 2. Here the integral changes from 0 to infinity. Here changes from 0 to infinity. F of x into cos u of t into cos u of x into dt du. Similarly, for this also pi by 2 integral 0 to infinity f of x into sin ut into sin ux dt du. Understanding? Now just look at the given Fourier integral is split into 2 different integrals. An integral, a Fourier integral, which contains only cos terms. This is called Fourier cosine integral. A Fourier integral which contains both sine terms, that is called Fourier sine integral. Now just look at, therefore Fourier sine integral. What is sine integral? A Fourier integral which contains only sine terms. So this is equal to pi by 2. Look at the integrals. 0 to infinity only. 0 to infinity, 0 to infinity, f of x into sine u of t, ut into sine ux into dt, du. It contains only sine part. That means what? This part is called Fourier sine integral. Now, the second part that is contains only cosine terms. So, this cosine term that is called Fourier cosine integral. The Fourier cosine integral is equal to pi by 2 integral 0 to infinity, integral 0 to infinity, f of x into cos u of ut into cos ux into dt into du. Now just look at. Now how a Fourier integral can be split into Fourier sine integral and Fourier cosine integral. No need to apply any special formula here. Just whatever the Fourier integral format we are having, just look at f of x equal to cos u of t minus x dt du. The output will be in terms of x only. Now it can be expanded as cos a minus b format. Here cos a cos b plus sin a sin b. Just look at. This is the next format. After that, because of these two, product of even is even, the limits changing from 0 to infinity, 0 to infinity. Because of product of two odd signals is also an even signal. Because of that, the limits are also changed to 0 to infinity, 0 to infinity. Thus, we got a main Fourier integral is split into an integral that contains only cosine terms and another integral which contains only sine integrals. Now, taking these two integrals separately, now an integral that contains only cosine terms, that is called Fourier cosine integral. An integral that contains only sine terms itself, that is called Fourier sine integral. These two representing the binary tree structure of this one. So root node, that is Fourier integral. Left is Fourier sine integral. Right is Fourier cosine integral. So these two are important concepts of Fourier integral. So one important point, just you have to make it, a Fourier integral that contains both cosine terms plus sine terms. A Fourier integral contains both cosine terms and sine terms in the form of what? Cos u of t minus x. But a Fourier integral, a Fourier sine integral, it contains only sine terms. It contains only sine terms. A Fourier cosine integral that contains only cosine terms. That contains only cosine terms. So this is the overall formula structure of Fourier integral, Fourier cosine integral and Fourier sine integral itself. Thank you. In the next session, we are going to discuss Fourier transforms from this one. Thank you, sir.